Today's lesson is to find the area of a pyramid, and I want to provide you the net. Here's the net. Now, the formula is S, which stands for the surface area, A, which is the area of the base, and P stands for the perimeter. So we have a hexagonal prism. So this right here is called the slant height. And this right here is the apothem. So let me start out by finding the area of the hexagon, which is the base. So the hexagon is the base here. So S A equals 1/2 little a times P. Now I'm finding the area of the hexagon, area of base. So A equals 1/2 times the apothem. In this case, it's 3 square root of 3. To find the perimeter, I know that one side is 6, and there's 6 sides. So 1/2 of 6 is 3. 3 times 3 is 9. 9 times 6 is 54. So the area is 54 square root of 3 inches squared. So now what we're going to do is we're going to find the surface area. So the surface area is the area of the base, which we already found, which is 54 times the square root of 3 inches squared, plus 1/2 the perimeter of the base. In this case, it was 36, times the slant height. In this case, it's 9. So let me go ahead and figure this out. So the slant height, the surface area is, I'm going to go ahead and figure this out. So the total surface area is 255.53 inches squared. The lateral area is just the area of each face of the triangles. So let me go ahead and highlight that. So it's these here. And we know that there are 6 triangles, since there's 6 faces. And it's going to be 6 times 6, there's 6 faces. So that's 36 times the slant height. So this right here is describing the area, the lateral area of the triangle. So we have 1/2 times 36, which is 18. 18 times 9 gives you 162 inches squared. So if they were asking for the lateral area, that would be the answer, 162 inches squared. A square pyramid has edges of 5 meters. So it's really important that you know that it's a square pyramid. Also, the edge is 5 meters and the slant height is 3 meters. What is the surface area of the perimeter? So surface area equals the area of the base. And we know the base is a square, so to find the area of a square, area is equal to the side squared. So this area is going to be 5 squared, which gives you 25 meters squared. So the area of the base is 25 meters squared plus, now we got to find the lateral area. This is describing the lateral area, so it's going to be 1/2. Now the perimeter, we know that each side is 5 meters and there's 4 sides. The slant height is 3. So to find the surface area, we get 25 square meters plus, I know that 1/2 of 4 is 2. 2 times 5 is 10. 10 times 3 is 30. So it's 30 square meters. So the surface area is going to be the sum of the two, which gives you 55 square meters. So that is the surface area. The lateral area, we've already figured it out. It's this part. That's the lateral area. So that's the area of the triangles. So that's 30 square meters. Problem 2, finding the lateral area of the pyramid. The pyramid in Cestius is located in Rome, Italy. Using the dimensions in the figure below, what is the lateral area of the pyramid? Round the answer to the nearest square meter. So what we're going to do is we have to find the area of each of these triangles. And there's a formula to figure that out. The formula is equal to 1/2 P, which is the perimeter of the base, times the slant height. So we have the lateral area equals 1/2. We have 30 meters for one side. And since we have 4, you're going to multiply times 4, times the slant height. The problem is we don't have the slant height. This is the slant height. We do know that the apothem is 1/2 of 30, and I figured it out right here. That is the apothem. And we know that the height of the pyramid is 36.4. So to find the slant height, we're going to use the Pythagorean theorem. So we have, so I'm going to write Pythagorean theorem. So we have 36.4 meters squared plus 15 squared. And let me write this again. What we're going to do is we're going to square 36.4 plus 15 squared, and that's going to give you the slant height. It's called c squared. So c is equal to the square root of 1,549.50, which is approximately 39.36. So if I'm going to find the lateral area, it's 1/2 of 30 times 4 times the slant height. In this case, it's 39.36. So I know 1/2 of 30 is 15. So I have to multiply by 15 times 4. So approximately the lateral area is 2,361.8. In this case, it's meters squared. We're going to continue to find the surface area of a cone. The radius of the base of a cone is 16 meters. The slant height is 28 meters. Remember, the slant height is this height right here. So we're going to go ahead and find the lateral area. In this case, to find the lateral area, it's going to be pi times the radius times the slant height plus pi radius squared. So we have pi, the radius is 16 meters, the slant height is 28 meters, plus pi, and the radius is 16 meters, and then we're going to square. So we're going to go ahead and multiply 16 times 28. So we get 448 pi meters squared plus, we're going to go ahead and square 16, which gives us 256. So we have 256 pi meters squared. And then what we need to do is we have to add both areas. So what you get is total surface area is 704 meters squared. Finding the total surface area of a 3D composite figure. In other words, composite means that we have two shapes that are put together. A company packages pencils in a cardboard container that is composed of a cylinder and two right cones. The containers are made from sheets of cardboard with an area of 10,000 centimeters squared. Assuming that 10% of each sheet of cardboard is waste, how many containers can be made from a sheet of cardboard? So we got to figure out the total area, which means it's going to be the lateral area of the cylinder, and it's going to be the lateral area of the two cones, which I already put there. So it's going to be the lateral area of the cylinder, and it's going to be the lateral area of the two cones. So let's work with the cylinder first. So we have 2 times pi. The cone has a radius of, the cylinder and the cone have the radius of 3. So it's times 3. Now the height of the cylinder is 12. So the radius is 3 centimeters. The height is 12 centimeters. So that's going to be the lateral area of the cylinder. We have 2 times pi, since there's 2 cones, times the radius, in this case it's 3. The slant height, this is a 3, 4, 5 right triangle. So the slant height is 5. So I'm going to go ahead and multiply. 3 times 12 is 36, times 2 is 72 pi. In this case, it's centimeters squared, plus 3 times 5 is 15, times 2 is 30. 30 pi centimeters squared. So I want to make sure that if I did this correct, I want to check again. 3 times 12 is 36, times 2 is 72. And then 2 times 3 is 6, 6 times 5 is 30. So I'm going to add both. So you get 102 pi centimeters squared. Now it states that 10% of 10,000 square centimeters, and I wrote this wrong. It should be 10%. So, well, I can do this. 10% of this amount is wasted. So let's go ahead and figure that out. 10% of that, so we have 10,000. And that's the total area that we're using. So 1,000. So you have 9,000. You have 9,000 centimeters squared to work with to make the cardboard figure. That's the total area of the cardboard. So I got to kind of roughly estimate what is 102 pi. So I'm going to go ahead and figure that out, which is 320.4, I'll say 0.5 centimeters squared. So to make one container, it's 320.5 centimeters squared. So if I have 900 to work with, then to figure out the amount that I can produce, you simply have to divide 9,000 centimeters squared by 320.5 centimeters squared, and estimate. That will estimate how many you can probably produce from that cardboard. 28 of those figures.